It is stunning news. The James Webb Space Telescope has found proof that the universe has quit expanding. The space industry is at a dramatic turning point. Does this potentially imply that the universe will soon come to a complete halt, and that we are nearing a big tear or a huge freeze, where the whole universe either tears apart or suddenly freezes? Researchers all over the planet are frightened and are examining the ramifications of these latest revelations for our current cosmological models. We must now ask ourselves fundamental questions about the nature of space and time. The idea of the expansion of the universe will soon be celebrating its 100th anniversary. During the 1920s in the USA, an astronomer named Edwin Hubble was exploring the then newly discovered galaxies. Imagine, that was the first time researchers realized that our Milky Way was not the entire universe, but only one galaxy among many. First, the Andromeda cloud appeared. Then more and more galaxies opened up before Hubble's eyes. The scientist was one of the earliest people on this planet to realize just how enormous the universe truly is. Hubble was not only confronted with this revelation, but he also saw something that astounded him even more. Specifically, the galaxies far away from us seemed to be moving away from us. How could this be explained? Hubble measured the movements and distances of the galaxies using the redshift of light. The farther away the light source is, the more the color spectrum of the light shifts toward red. Hubble observed galaxies, their directions of movement, and estimated their velocities. In doing so, the scientist noticed a linear relationship, which later became known as the Hubble constant. This states that distant galaxies are moving away from us in proportion to their distance. Hubble published his groundbreaking discovery in 1929, later combining his discovery with the theory of a Belgian priest and physicist who had been studying the newly discovered galaxies around the same time as Hubble. Georges Lemaitre had already proposed in 1927 that the universe was expanding from an original state of high density and temperature. This idea later became known as the Big Bang Theory. Lemaitre's work was largely based on the field equations of Albert Einstein's general theory of relativity, which predicted that the universe could be dynamic, expanding, or contracting. Along with Hubble's discovery, Lemaitre's idea and Einstein's equations of relativity became the foundations of our cosmology. Little has changed in these foundations for almost 100 years, until the James Webb Space Telescope entered the stage of science. This revolutionary new telescope is now revealing a series of phenomena that are no longer compatible with the current theories of standard cosmology. While it is now common knowledge that physics is facing a massive crisis due to Webb's revelations, it is less well known that these issues and challenges are not new. In fact, scientists have long observed that the universe does not behave quite as expected by calculations, and they have even found that for some puzzling reason, it has stopped expanding, at least as far as our old ideas of physics are concerned. Is our universe a whirlpool? It is an exciting time, filled with news, noise, and debate among astonished scientists. One of the most significant issues in assessing the current state of our universe is the problem of dark matter and dark energy. Observations of the rotation curves of galaxies and the cosmic microwave background radiation showed that the visible matter in the universe is not sufficient to explain the observed gravitational effect. This led to the hypothesis of dark matter, an invisible substance that makes up about 27% of the total matter-energy density of the universe. But what if our calculations of the dynamics of our universe were completely wrong? Webb's revelations provide evidence that we have so far completely misunderstood fundamental aspects of the universe, and this may start with the rotation of galaxies and certainly does not end with the expansion of the universe. Where these phenomena do not appear, the presence of dark matter and energy would not be necessary. Another critical issue arose in the late 1990s, when scientists discovered that the expansion of the universe is accelerating. This discovery supported the hypothesis of dark energy, which supposedly drives the expansion and could be responsible for changes in the constants. Again, we may have made a huge mistake here. If our previous measurement techniques were wrong or based on entirely false assumptions, there may be neither a linear expansion nor a space in which the universe is expanding as Hubble and Lemaitre proposed. In fact, Some measurements suggest that our universe could be much more like a giant whirlpool, fed by various sources. Imagine how energy and the building blocks of matter are funneled into this space through different sources. In some areas, this would lead to more turbulence, while in others, the dynamic would be smoother, much like in a whirlpool whose jets are far apart. The idea of the expansion of the universe would then cease to exist. Instead, scientists would have to admit that their conclusions were based on observational errors. This model of the universe is not yet accepted, as further key evidence is lacking. However, recent observations from the James Webb Space Telescope are pushing these assumptions forward once again, and slowly scientists are facing uncomfortable truths. Bits of insight. Are we nearing the enormous tear, the enormous crunch, or the large freeze? It sounds alarming because scientists have confirmed that an expanding universe would need to end in a grisly situation eventually. Envision the universe continues to expand and extend until it becomes weak and breaks. Here we are at the possibility of the large tear, a speculative thought of where the development of the universe will lead. Tragically, the huge crunch is not a substantially more hopeful variation, as the universe will ultimately implode when depleted. If we follow this speculation, the expansion stops at a certain point, reverses, and all the quality of the universe collapses. Let us also consider the enormous freeze, where the universe has spent all its energy eventually and is frozen in a sort of shock state. In all these cases, the expansion stops unexpectedly, and there is a sort of breakdown or shock state. It's truly frightening, since scientists have found areas in the universe that highlight an impending finish to the expansion. Are we nearly the breakdown of the universe? The most recent information suggests that the structure of the early universe was significantly more complicated than previously thought, and that there may be unknown physical processes influencing local expansion rates. This could lead to key changes in our understanding of cosmological standards. The ideas of dark energy and dark matter may need to be completely revised, and thoughts such as a universe that is timeless and fed by many sources are picking up speed again. The possibility of everlasting expansion comes from the work of physicist Alan Guth, who proposed the first hypothesis of infinite expansion in the mid-1980s. This hypothesis was later developed further by Andre Linde, who introduced the idea of everlasting expansion. The vast expansion hypothesis states that the universe went through a period of dramatic, all-quick expansion in the very first minutes after the Big Bang. Linde expanded this hypothesis by showing that in an inflationary universe, certain areas can continue to grow dramatically, while other areas stop their expansion and undergo normal growth. This leads to the idea of a multiverse, where new bubble universes are constantly being created, each of which may have its own physical properties. In Linde's model of timeless expansion, there is no clear beginning or end to the universe. Rather, the process of bubble formation continues infinitely, suggesting an ever-existing multiverse. Has the universe truly come to a stop? It might sound odd, but it's true. Our universe has, in a sense, come to a halt. The expansion, as far as we knew it, has definitely come to a temporary stop. All elements in the universe are at a halt right now, as they were just ideas in our minds or speculations on paper. We are now experiencing a huge freeze, a shockwave that has brought our science to a halt and incapacitated it. The Webb's images and estimation results are putting the space industry and science in a condition of vulnerability. All images that show the young universe or that allude to enormous scale structures criticize the old ideas. The progression of new discoveries does not stop. New estimation data that no longer fits the complete picture of the universe, as researchers have drawn it for nearly a century, is currently falling as imagined by the possibility of the huge crunch. Today, like never before, the question arises regarding whether all these theories are simply wrong and whether we may be living in a universe that is far more dynamic and variable than we thought. For a long time, researchers have constructed a house of cards and built theories on unstable foundations. Nearly our entire cosmology depends on dark matter and dark energy, which in the end could never be proven. Alternative approaches, such as tired light, the Mond hypothesis, the hypothesis of holographic gravity, or the hypothesis of the variable speed of light, demonstrate that the universe can also be explained based on entirely different parameters. Tired light goes back to the Swiss Fritz Zwicky in the 1920s. He hypothesized that the light from far-off galaxies loses energy over enormous distances and thus appears redshifted. This theory was an alternative explanation for the expansion of the universe. Similarly, the theory of the variable speed of light states that the physical properties of light may have been different billions of years ago than they are today. If this is true, our entire cosmic perspective is incorrect. Mond hypothesizes something similar. The modified Newtonian dynamics hypothesize that gravity is not a constant quantity either, but has been subject to shifts over time. Holographic gravity is even more exciting. This is because Eric Verland's idea suggests that gravity is not a fundamental force, but results from the underlying principles of quantum information and thermodynamics. In plain language, this would mean that our universe functions like a giant hologram, in which we ourselves are possibly the co-creators of the physical quantities we can observe. If we combine quantum mechanics with the material universe, it could even be that we, ourselves, create the problems that our inherent science is now facing.